Okay. Of course, at the beginning, I said that the lesson was on concavity and second derivative test. So now we're going to talk about the second derivative test. Now, your first derivative test, I know we used our first derivative to do increasing and decreasing, but if you go back and look at your notes, the part that I actually labeled first derivative test was in reference to determining your extrema, your maxes and your mins. So second derivative test is actually going to determine maxes and mins for you as well. But you're going to get it from the second derivative instead of the first derivative. Now, honestly, when I have a choice, I do first derivative. But when you do your homework and it specifies to use second derivative test for maxes and mins, then make sure that you do those problems that way, because you will have that specified on the test as to which way I want you to do it. Okay, so first statement there, of course, already states what I have already said. Extrema can be determined from first and second derivatives both. The second statement there is a reminder that your extrema can only occur at critical numbers. Okay, now here's how your second derivative is going to work. So if your second derivative, if you evaluate your second derivative at your critical number and you get something that's greater than 0, then that actually tells you that you have a minimum. Okay, I know it's right the reverse of what you would think, but remember, we're using second derivative this time. And if your second derivative evaluated at your critical number is negative, is something less than 0, then that actually tells you have a max. If it comes out to be exactly equal to 0, the test fails and you have to go back and use first derivative test. So that's one reason why I would, if I have a choice, I just always go with first derivative test, because if it fails, you have to go back to it anyway. Now, the reason why this is right the opposite of what you would think of, like greater than meaning a min, less than meaning a max. If you remember, we just finished doing concavity with second derivative, and you remember, if your second derivative is greater than 0, it's concave up. So if you have a section that's concave up, see, that's going to put a low point down here at the bottom, which would indicate that you have to have a min. If your second derivative is less than 0, we learned that that meant concave down. So if you have a section of your graph that's concave down, then that puts a point up here at the top, which actually would give you a max. So that's why it's right the opposite of what you think it would be. All right, so here's the example we're going to look at. Okay, so first of all, let's talk about domain. And this is a polynomial. Therefore, our domain's negative infinity to positive infinity. We're not going to have anything left out that we have to worry about. Okay, first derivative. Of course, these are just power rules that you would have with taking the derivative here. So negative 15x to the fourth minus 15x squared. I'm sorry, plus 15x squared. And then second derivative is going to give us negative 60x to the third plus 30x. Okay. Now, remember your critical numbers. I'm just going to say C and S here for critical numbers. Remember, that comes from your first derivative. Okay. So you've got to set your first derivative equal to 0. Okay. I mean, we're going to end up using the second derivative, but to get the critical numbers themselves, you have to get that from your first derivative. Okay, I have a common factor of, and you could take out a positive 15 or a negative 15. It doesn't matter, but I'm going to go with the negative. So if I were to factor out negative 15x squared, then I'm left with x squared minus 1. So negative 15x squared equals 0 is going to give me x equals 0. And x squared minus 1 equals 0 will end up giving me, of course, that's x squared equal 1, so x is equal to plus or minus 1, okay? So these are going to be my critical numbers, and what I'm going to do is substitute those critical numbers into my second derivative, okay? So, I'm going to do f double prime. You know, always pay attention to whether, like if I'm just writing just f with no tick marks, that means I'm referring to the original function. If I put just f with one tick mark, that means I'm substituting into the first derivative. This time I'm told to substitute into my second derivative, because remember, we're doing second derivative test. All right, so let's just start with the 0. So if you substitute 0 into the second derivative, then you're going to get 0. Okay, then if you substitute -1 into the second derivative, then you're going to get something that's positive. Now, again, I'm going to let you put it in the calculator and see that. I'm just going to put a plus sign because the actual number doesn't matter. I just want to know, is it something that's positive or is it something that's negative, okay? Then I'm going to substitute +1 into the second derivative, and that's actually going to give me something that's negative, okay? Now, if you look back at your rules, one of the rules stated if your second derivative is greater than 0, then that's where you're going to have a min. So this is going to indicate that you have a relative minimum. Okay, if your second derivative is less than 0, it's something that's negative, then that's going to be a relative maximum. And in this case, equals 0, remember, tells us that the test fails, okay? So here's the thing, you get a situation in which your test fails, that just means that it fails the second derivative. You have to go back to the first derivative and do first derivative test, okay? Just because it fails, that doesn't mean that there's not a max or a min. Now, there may not be, but there still could be a max or a min. So from here, we've got to go back to the first derivative, and we're going to do it just like what we did before, and we're going to do a sign graph. Now remember, my critical numbers are -1, 0, and +1. Now, of course, 0 is the only place that it failed. So like when you're picking a test number, I'm just going to use -1/2 and +1/2. I'm not even going to bother testing these because I already know what happens at -1 and +1. I just want to know what happens at 0, so I'm just going to test on either side of 0, okay? I went ahead and put these in here because you got to make sure that you pick a number that's between these two. So if I see those there, I'll make sure that I'm picking a correct number. Okay, remember, this is first derivative. So you need to substitute -1/2 into your first derivative. Okay, that's going to give you something that's positive. Okay, then you're going to substitute +1/2 into the first derivative. That's actually going to give you something that's positive. Now, remember what we learned from first derivative was increasing and decreasing. This section's increasing, this section's increasing, but you're only going to have a max or a min if it changes, you know, from increasing to decreasing or vice versa. So actually what we've learned is right here at 0, there is no extrema. Now, is this why this test over here failed? No. You can still get it to fail here, come do your first derivative test, and still find that it's a max or a min, okay? So you still have to fall back to this just to double check. Okay, now we need to know the actual ordered pair for the max and the min. Of course, we found these two. So you've got to substitute the -1. Now remember, I didn't put a tick mark here, so that means that I'm plugging -1 back into the original function, okay, because I'm completing an ordered pair, a point that is on this graph, so I have to go back to the original. So if I were to substitute -1 into the original, I'm going to get -2. So that means -1, -2 is my min. And then I've got to substitute +1 back into the original function, which is going to give me +2. So that would be the 0.12 that's going to be my max. So this is what we're looking for. These order pairs as being our answer.